In the fall of 2017, high atop Hawaii's volcanic summits, astronomers caught sight of something that would upend our understanding of the cosmos. A faint, swift speck of light darted across the night sky, unlike anything they'd ever seen before. This wasn't just another asteroid or comet. It was the first confirmed object from another star system, a true interstellar visitor, passing through our solar system and leaving scientists both awestruck and unsettled. They named it Oumuamua, a Hawaiian term meaning a messenger from afar who arrives first. But with the latest findings shared by Michio Kaku, that name now carries a far more ominous weight. Unlike any comet or asteroid on record, Oumuamua showed no glowing tail or cloud of gas. Yet as it neared the sun, it sped up in a way that defied explanation, almost as if it was being propelled by something unknown. Kaku's new data hints this was no mere coincidence. Its brightness changed rapidly, suggesting a bizarre, stretched-out cigar-like form, possibly 10 times longer than it was wide. This tumbling, highlighted in Kaku's chilling analysis, only deepens the enigma. The object's reddish tint, once blamed on cosmic radiation, is now under fresh scrutiny. Kaku's research points to surface features that don't match any known natural object, raising disturbing questions about where it truly came from. Its path was unmistakable. Oumuamua was just passing through, moving so fast that not even the sun's gravity could hold it. But Kaku's findings suggest its journey may have been far from random. This extraordinary mix, an interstellar origin, strange shape, unexplained acceleration, and now Kaku's unsettling data, has reignited fierce debate. What is NASA keeping from us? Could this be a relic of an alien civilization, or something even more mysterious? As scientists sift through the limited evidence, the questions only multiply. Kaku's revelations have cast a shadow of doubt. Was Oumuamua a piece of alien technology, or a natural oddity that challenges everything we thought we knew? With only a short window to observe before Oumuamua disappeared, researchers scrambled for answers. Now, with Kaku's new insights, it seems we may have overlooked something truly extraordinary, something NASA might not be ready to disclose. In the end, Oumuamua slipped away into the vastness of space, leaving behind a cosmic mystery and, thanks to Kaku's chilling revelations, a lingering sense of unease among scientists everywhere. Its brief visit has forced us to confront the boundaries of our knowledge. With these new revelations, we're left to wonder, what else is out there, and what secrets might still be hidden among the stars? As a theoretical physicist, I've always sought to bridge the gap between the complex world of science and the everyday curiosity of people everywhere. My passion is to make the mysteries of the cosmos accessible to all, to inspire wonder and understanding about our place in the universe. When Oumuamua appeared in our solar system, it was more than just a scientific curiosity. It was a rare opportunity to ask some of the biggest questions humanity has ever faced. Are we truly alone in the universe? What else is out there, waiting to be discovered? Science at its core demands open-mindedness and a willingness to challenge our assumptions. We always look for natural explanations first, but when the evidence stubbornly defies our models, we must be prepared to consider the extraordinary, even the seemingly impossible. Oumuamua's behavior was so anomalous, so unlike anything we'd seen before, that it forced us to rethink our categories for celestial objects and reconsider what we thought we knew about the universe. For decades, the search for extraterrestrial intelligence has focused on detecting radio signals from distant stars. But what if the first evidence of another civilization isn't a signal, but a physical object passing through our solar system? The universe is unimaginably ancient and vast. It's entirely plausible that other civilizations exist out there, perhaps millions or even billions of years ahead of us in technology and understanding. When I discuss Oumuamua, it's not to create sensational headlines or stir up controversy, but to encourage rigorous, imaginative debate. and to push the boundaries of what we consider possible. The scientific method requires us to propose bold hypotheses and then test them relentlessly against the evidence, no matter where it leads. Oumuamua challenges us to be better scientists, more curious explorers, and to keep our minds open to the wonders that await us. The universe is stranger, more mysterious, and more wonderful than we can possibly imagine, and that's what makes the journey of discovery so exciting. The key to Oumuamua's mystery is its acceleration. Normally, comets accelerate due to outgassing, but telescopes detected no gas, no dust, nothing. The push was smooth and consistent, weakening precisely with distance from the sun, matching the mathematical pattern of solar radiation pressure. For sunlight to move an object this way, it would need to be extremely thin, less than a millimeter thick. Nature doesn't make kilometer-scale objects that are paper-thin. This points away from natural explanations and towards something engineered. The data suggests Oumuamua could be a light sail, a technology designed to be propelled by starlight. If true, this would be the first evidence of extraterrestrial technology. The idea that an artifact from another civilization passed through our solar system is both exhilarating and unsettling. We may have witnessed a creation from the stars visiting us. This shifts the conversation from science fiction to observable data. The implications are profound. When astronomers first spotted Oumuamua, early observations suggested it was shaped like a long, thin cigar. This was a striking image, but it quickly became clear that this shape didn't fit with some of the more intriguing theories, like the solar sail hypothesis, which proposes that an object could be propelled by sunlight across interstellar distances. If Oumuamua really was a tumbling cigar, its movement would have been unpredictable and erratic, with wild changes in speed and direction as it spun through space. But as scientists analyzed more data, they reconsidered its shape. They found that a flat, pancake-like disk actually fit the observations much better, especially when it came to explaining its unusual motion. Picture a thin, wide coin flipping gracefully through the cosmos. This shape would naturally cause the flickering brightness we observed from Earth, and it would also allow for the smooth, steady acceleration that puzzled astronomers. In fact, a pancake shape is exactly what you'd expect if Oumuamua were a light sail, an ultra-thin, broad surface designed to catch and ride the pressure of starlight, just like a sailboat rides the wind. Two independent observations, its unusual motion and its flickering light, both point to a thin, flat object. Some even suggest it could be manufactured, not natural. If Oumuamua was actually a piece of alien technology, its motion might have been intentional, perhaps scanning its surroundings or stabilizing itself as it traveled. It's possible that it's a relic from a long-lost civilization, drifting silently through the galaxy, or maybe even an active probe that simply chose not to communicate with us. After all, the lack of radio signals doesn't rule out artificial origins. A silent car is still a car, even if it makes no noise. The pancake model transforms Oumuamua from just another strange rock into a potential artifact, something that could change our understanding of the cosmos. Science moves forward by finding simple, elegant explanations for complex mysteries, and by questioning what we think we know. In this case, all the evidence seems to converge on something truly extraordinary, an object that challenges our assumptions and invites us to imagine what else might be out there, waiting to be discovered. If Oumuamua was artificial, what was its purpose? Its silence is unsettling. Was it a defunct machine or a stealthy observer? One theory: it was a reconnaissance probe sent to survey star systems quietly. Its trajectory brought it close to Earth, possibly to scan for life or technology. If so, it could have analyzed our planet and moved on, its findings stored for later. A civilization capable of sending such probes would be vastly superior to ours. We'd be like ants trying to understand a passing human. The probe could have been a scout, assessing us as a potential threat or resource. Its departure doesn't mean the story is over. It could be reporting back. The discovery forces us to reflect on our place in a much larger cosmic community. Science demands we explore all possibilities, especially natural ones. One theory, Oumuamua was a nitrogen iceberg, a fragment from a Pluto-like world. As it neared the Sun, nitrogen gas could provide the push, but this requires a rare shape and unlikely survival through interstellar space. Another idea, a hydrogen iceberg formed in cold molecular clouds. Hydrogen ice would be light and invisible, but it likely couldn't survive the journey. Each natural explanation requires special, improbable conditions. The artificial light sail hypothesis, however, fits all the data, acceleration, shape, lack of coma, in one coherent package. Occam's razor suggests the simplest explanation is often correct. In this case, the simplest is also the most revolutionary. Oumuamua sits at the edge of our understanding, challenging us to think bigger. The debate continues, but the mystery endures. The mystery of Oumuamua has sparked intense debate among scientists. Many favor natural explanations, arguing that extraordinary claims require extraordinary evidence. Oumuamua is the first interstellar object we've observed up close. It could represent a new class of natural objects. Some warn against invoking aliens too quickly, urging us to exhaust all natural possibilities first. Others, like Professor Avi Loeb, argue the artificial hypothesis fits the data best. This debate is the strength of science. It pushes all sides to refine their theories. The object is now beyond our reach, so we must analyze old data and prepare for future visitors. New observatories, like the Vera C. Rubin Observatory, will soon help us find more interstellar objects. Each new discovery will test our ideas and bring us closer to the truth. The scientific process thrives on such mysteries. Whatever Oumuamua was, its visit changed our perspective forever. We now know our solar system is not isolated. Interstellar objects pass through regularly. If Oumuamua was natural, it expands our understanding of planetary systems and cosmic chemistry. If it was artificial, it would be the greatest discovery in human history. Proof we are not alone. Such a revelation would reshape our philosophy, society, and sense of identity. It would unite us as Earthlings, part of a larger galactic community. Oumuamua has ignited our imagination and scientific curiosity. We're now designing missions to intercept future interstellar visitors. The universe is waiting, filled with wonders and mysteries. Our journey to the stars has just begun. We must be ready to answer the next cosmic messenger.